All right, so this is going to be a quick review of stuff from in our book from chapter 3, but this is actually part of topic 5, which is geometry and trigonometry. So it seems kind of weird that this would be in with the other stuff, but it is. So here we go. First of all, a Cartesian plane, that's what you're used to looking at when you talk about graphing something. You graph it actually on a Cartesian plane. That is made up of a two-dimensional flat surface that is divided into 4 quadrants. And those quadrants are the result of a plane divided by 2 straight lines. Sorry, we're spinning here. 2 straight lines. Intersecting at 4 right angles and meeting at a point called the origin. Okay, the horizontal axis, of course, is the x-axis, and the vertical axis is the y-axis. Now, the quadrants are numbered starting here with quadrant 1, and then here quadrant 2, quadrant 3, and quadrant 4. I don't have a really good reason for you why it's in that order, but in trig, when you get higher in trig, we learn that angles start here in quadrant 1 and they go around this way. So in that respect, it makes sense that it's 1, 2, 3, 4 in that order. Otherwise, I don't have a good reason for you. If you want to find the distance between 2 points on a plane, you can use your distance formula here. Now, it doesn't matter which one is your x1 and your x2. You know, it could be your opinion that this, excuse me, that this point here is x1, y1, and this point over here is x2, y2. You'll end up with the exact same answer no matter what. But do make sure that you are using that formula there correctly. That is in your formula booklet. Same thing with midpoint formula. It doesn't really matter which order you add the x's in. You'll end up with the same answer there either way. So first example here is a little bit different. Find the value of b, given that a is -4, 3, b is b, 7, and they are the square root of 97 units apart. Well, what they've done here is they've given you your distance, and right? They've given you a point, but you're missing a letter. So we're going to pretend like we're finding the distance, except that we already know what the distance is, and we'll solve our equation from there. So, here. Okay, so using the formula there up above would look something like this. We're going to take the square root of x2 minus x1, so b minus -4 squared. Now, you don't have to write minus -4. You can go ahead and make that be plus 4. Plus 7 minus 3 squared is equal to the distance, and the distance is the square root of 97. So just, again, plugged it into that formula. Now, as I simplify this, and you don't have to show as many steps as I'm doing here, minus a -4, that's going to be a plus 4, b plus 4 squared. 7 minus 3, that's going to be 4 squared. And then what I'm going to do here is to solve this equation, I'm going to have to square both sides. As long as you're squaring both sides, you can square both sides. So when I square this side, I get rid of the square root. When I square the other side, I get rid of the square root. So that's actually the equation that we're going to solve. Now, if I continue simplifying this here, this right here, I'm going to kind of pull up here since I'm running out of space. That's going to be b plus 4 squared plus 16 is equal to 97. b plus 4 squared is equal to 81. Okay. Now, you might wonder, why didn't we square the b plus, excuse me, why didn't we square the b plus 4? Because by leaving it like this, I'm making the question easier. I can take the square root of both sides. If I do that, I end up with b plus 4 is equal to 9, and also b plus 4 is equal to -9. And then I solve, and I'm going to end up with 2 answers. b is equal to 5, and b is equal to -13. Now, that might seem kind of weird to have 2 answers, but think about when I put this b value in here, and I told you how it didn't really matter which order you subtract things in, I need this number right here. Sorry, you can't see that. This number right here to be a certain value. So in this case, I need this number right here to be an 81. Well, I can get that two ways. That can be an 81 if it's a positive 9. It can be an 81 if it's a negative 9. So plugging 4 in gives me a positive 9, and plugging a negative 13 in gives me that negative 9. Now, coming back over here, if it didn't occur to you to leave that as squared and you went ahead and squared it, you would just get everything onto one side and then either factor or use the quadratic formula, and you'll end up with the same two answers. But I think this way is quicker. Just don't forget that you need to set it equal to a positive and a negative. Okay. All right, next we have the slope or the gradient formula that is in your formula booklet. Now, a lot of times in IB, instead of seeing the word slope, you'll see the word gradient, so make sure that you're okay with that. Real quick review here of slope. It doesn't matter which one's your y2 and which one's your y1. We can take negative 5 minus 3. Negative 2 minus 4. I almost wrote the 4 first, which would have been okay if I had put the 3 first on top, but I didn't. So that's going to be negative 8 over negative 6. Reduce that, my negatives will cancel, and I end up with 4/3. Okay. Make sure that you leave that as a reduced fraction. Don't make it a mixed number. If they ever give you a slope as a mixed number, change it to an improper fraction. A couple other formulas that you will see in your booklet, the gradient intercept or slope intercept form. This is kind of weird. In America, we're used to seeing y equals mx plus b. They call it y equals mx plus c for whatever reason. That is in your formula booklet, and so is this one here called standard form. That looks a little bit different than what, again, we normally think of in America. Both those formulas are in your formula booklet, but it just says generically that it's the equation of a line. So it doesn't say which one is, gradient intercept and which one's standard form. Also, all this information right here is super helpful to find your slope and your y-intercept and your x-intercept when you're in standard form, but none of that's given to you. So if you want to know those things, you have to memorize those things. Point gradient form or slope intercept form point slope form is what we call it. That one is not in your formula booklet, but that is something that you use often, so make sure that you know how to use that. Okay. So, first example here, we're going to write an equation that goes through the following 2 points in point slope, essentially slope intercept, and standard form. So, to do all of those things, we're going to need to know the slope. So, let's find the slope here first. My slope is going to be negative 5 minus 3, negative 2 minus 4. Hey, that looks familiar. That's 4/3. We did that actually up above. Okay. Now for the point gradient, pick a point. Doesn't matter which point that you use. Personally, I like to use the point that's all positive if I have one, because that's going to be easier to plug in, but the other one is also acceptable. So for my point gradient form, I kind of abbreviated there, that's going to be y minus 3 is equal to 4/3 x minus 4. And you would just leave it. Now, we could also again say y plus 5 is equal to 4/3 x plus 2. Minus a negative, we want to change that to a plus. So both of those would be acceptable. Now, gradient intercept or slope intercept, we're going to do one of two things. We can take one of these equations right here, and we can distribute, and we can add the other number there. And that'll work just fine. I want to show you a different way, though, of doing it that maybe you might like better. This is the form that we want to write our equation in. If you write mx plus b, it's not a big deal, but that's the one that's in your formula booklet. In order to write something in that form, I need my slope and I need my y-intercept. Well, I already know my slope, but I also know a point. I know x and y, so I can take a point, and again, I'm going to use the positive point. I can plug it into this equation along with my slope, and I can solve for c. And once I know c, I can go back and plug in my slope and my intercept, and that'll be my equation. So 3 is equal to 16/3 plus c. I'm going to have to combine fractions here, so I'm going to make this 9 be this 3 be a 9/3. So I have common denominators. When I subtract 16/3 from both sides, I end up with negative 7/3 is equal to c. So my equation then in this form would be y is equal to 4/3 x minus 7/3. And again, you'll get that same thing by taking either of these point gradient forms over here, either one of them, and distributing, you'll end up with the same thing. I don't care how you do it. You decide what seems best for you. Okay, and then standard form, I'm going to take, again, either one of these, and I'm going to get everything onto one side, equal to 0 always. And then two other kind of hidden things that they don't tell you. They normally want your A and your B to be, and your D to be integers, so no fractions, and they want your A value to be positive. So that being said, first of all, with my equation right here, I'm going to kind of carry this over here. I'm going to start off by multiplying everything times 3 to get rid of the fractions. So 3y is equal to 4x minus 7. Yes. Now, I want to get everything onto one side. I also want my a, which is my x term, to be positive. So I'm actually going to move everything to the right side because I only have to move one thing. That's going to be 4x minus 3y minus 7. Now, it doesn't matter that the equals on the left as opposed to being on the right. That's fine. But again, you want your a value here to be positive, and you don't want any fractions. Okay. All right. Next, we have parallel lines. So you should remember from Algebra 2 and from Geometry and from Algebra 1, parallel lines have the same slope. Perpendicular lines have either a product of their slopes of -1, or they are a negative, and actually, this should say here, opposite reciprocals. So you've got a 3/5, you've got a -3/5 kind of thing. If they're just reciprocals, that's not anything. Okay. So for example, determine whether the lines here are parallel, perpendicular, or neither. So I need to think about what the slope is first. So both of these equations, I need to think about them being in my slope-intercept form or my gradient-intercept form. So here, I want them to be equal to y. So 2x minus 5 is equal to y. My slope would be 2. In this case, 4x plus 3 is equal to 2y. Divide everything by 2. 2x plus 3/2 is equal to y. M is equal to 2. So since they are both 2, these would be parallel. Okay. On the other side, 3x plus 28 is equal to 4y. Divide everything by 4, I get 3/4 x plus 7 is equal to y. So my slope is going to be 3/4. Over here, in this case, my y is positive where it is, so I'm going to move the other stuff to the other side. So 3y is equal to -4x plus 6. Divide everything by 3, I get y is equal to -4/3 x plus 2. And I'm just looking at my paper here real quick. I did this wrong in my paper. So luckily I caught it here as I was doing it for you. Here is a slope, here is a slope. They are reciprocals and they are opposites. So this is perpendicular. Now on my paper I was missing a negative for that 4/3, so they were reciprocals but they weren't opposites, so that would be neither. But I just messed up. So okay. Perpendicular bisector. A perpendicular bisector is a line that passes through a midpoint and is also perpendicular at that midpoint. So let's find the equation of a perpendicular bisector of a segment AB, where A is equal to and B is equal to, and we'll put that answer into standard form. Okay, so first of all, I have to find where the midpoint is because that's where the perpendicular bisector is going to go through. So that's pretty easy to do here. My midpoint is going to be 1 plus 3 over 2 and 2 plus 1 over 2. So that's, let me actually put that down here, that's going to be 4 over 2 and 3 over 2, which is 2 and 3/2. You could say 1 1/2 there, I don't really care. Okay, next, I need to figure out what the slope of AB is, because the line that is going to be perpendicular to that is going to be perpendicular to the slope of AB. So the slope of AB, would be 1 minus 2 over 3 minus 1. So that's negative 1 over 2. So my perpendicular slope, you might remember that from geometry there, that symbol, would be a positive 2. Flip the 1/2, which is 2, make it opposite, that's a positive 2. So now I want to find a line through 2 3/2 with a slope of 2. Okay, well that would be pretty easy to do with my point slope form. So it's going to be y minus 3/2 is equal to 2x minus 2. The first 2 is my slope, the second 2 is the 2 from my point. Make sure you don't get them backwards there. That's going to be y minus 3/2 is equal to 2x minus 4. At this point, I'm trying to get this into standard form. Remember, standard form doesn't want any fractions, so let's go ahead and take everything times 2. 2y minus 3 is equal to 4x minus 8. And then we want to put everything on to one side with my a value being positive. I'm going to infringe on this space down here a little bit. So I'm going to subtract everything from the left and move it to the right. 4x minus 2y, sorry, I'm going to actually be adding the 3. That's going to give me a negative 5 right there. So this is in standard form. All right, next. We are going to talk about a triangle here, properties of a triangle. So we're going to show that this triangle here is a right triangle by finding the slopes of the segments, and then we're going to graph the triangle. Now there's actually 2 ways you can prove that something is a right triangle. We could also find the lengths of each of the sides, and then if we plug that into the Pythagorean theorem and it works, I end up with a true statement, then it is a perpendicular, or that it is a right triangle. But this says to specifically use my slopes here. So we're going to plot our points here. 12, 13, 14, down 1. 10, 3. 10, negative 3. 1, 2, 3. And then 6, 7. So this was A, this is C, this is B. Now, since I specifically said to use the slopes, if this were a right triangle, this is where it looks like there's a right angle. So just to save myself some time, let's just find the slope of AC and BC and see if they're perpendicular. If not, since it says to show that the triangle is right as a right triangle, that means that it is. So that means pick 2 different ones, because it's got to be. So the slope of AC, okay, so let me actually write the points here. Being that they're not next to each other up above, it makes it a little bit harder to do. So AC, I'm going to take 7 minus negative 1 over 6 minus negative 14. So that's going to be 8 over 20, which is 4/5. Okay. Then we have, let's see, BC. And BC is 10, negative 3, and 6, 7. So 7 minus negative 3, 6 minus 10. That's going to be 10 over negative 4, which is negative 5/2. Hold on. Back up to our 8 over 20. How about if that's a 2/5 instead of a 4/5? Now, obviously, you can't just change the numbers to make them work here, but I had the wrong number written down there. So since those are opposite reciprocals, since they multiply to give me negative 1, that's another way you can check it. They are perpendicular, so it is a right triangle because my slopes there are perpendicular. So you would need to make sure that you write that statement out, that it is a right triangle because these slopes are perpendicular, which forms a right angle, something like that. But they wouldn't want you to just stop there because, all right, so what does that tell me? Like, you need to finish that statement out. Okay, for sake of time, I'm not going to finish writing it out, but make sure that on a question in your homework or your test or whatever that you would actually say that. Okay, a couple other things here. Point on the line. If a point's on a line, when you plug it into the equation of the line, you will get a true statement. So find t if 3 comma t lies on a line with an equation of 4x plus 5y equals negative 1. So let's plug that in. 4 times 3 plus 5 times t is equal to negative 1. 12 plus 5t is equal to negative 1. 5t would be negative 13. T would be negative 13/5. Now, when I first did that question, it kind of freaked me out a little bit because of the answer that I got, but that's what it is, so that's what we go with. But do kind of double check just to make sure that, yeah, no, it's just a yucky answer, okay? Next, intercepts. Intercepts are where a line cuts off the x or y axis. So if we want to find where the line 5x minus 3y minus 12 equals 0 cuts off the axes, we're going to find the intercepts. So the intercepts are going to be where the x value is 0 and where the y value is 0. So if we want to find the x-intercept, that's going to be where the y value is 0, because that's where it will cross the x-axis. Think about that for a minute. If the y is 0, it's going to cross the x-axis somewhere. So that's going to be 5x minus 3 times 0 minus 12 equals 0. So 5x minus 12 equals 0. 5x equals 12. X equals 12/5. Sorry. I don't care if you write that as a point, but in case you're asked to, that would be your point. Okay, y-intercept, and you don't have to show as much work as I do. You know that when you take it times 0, it's going to cancel out, so you could just cancel it out instead of writing it down. Negative 3y is equal to 12, because the 5 times 0 is just 0. Y is equal to negative 4, so 0, negative 4. Okay. All right, couple more things here. Write the equation of a line in standard form that has a gradient of 5 and a y-intercept of negative 4. Well, you can do this a couple different ways. A y-intercept of negative 4 would be a point of 0, negative 4. But hey, if the y-intercept is negative 4, that means that your c is negative 4. So y equals mx plus c, or for us, y equals mx plus b. They gave me the slope, and they gave me the y-intercept. So there's an equation. I just need to put it into the standard form here, and sorry, that should say D. All right, so let's move everything to the right. 0 is equal to 5x minus y minus 4. And that's it. Okay. All right, next, let's write this one in point slope form that has a line of gradient 3 and passes through the given point. Okay, so this is pretty straightforward. Y minus negative 1, and again, you can just go ahead and write a plus 1. 3x minus 2. Y plus 1 is equal to 3x minus 2. And stop there. Now, it's hard for me to stop there. In fact, in my notes, I had to cross out because I kept on going. That's all they want. Okay, but it would be easy to put it into those other forms from there. Next, write the equation in gradient-intercept form given that the line passes through the 2 points there. So I need my slope first. So that's going to be negative 6 minus negative 5, 7 minus 2. That's going to be negative 6 plus 5, 7 minus 2, negative 1 over 5. Okay. Now pick a point, any point. Again, it doesn't matter which one. I'm going to pick this point, honestly, just because it's first. So y plus 5 minus a negative equals negative 1/5 x minus 2. Again, if you need to write the y minus negative 5, do that. I just went ahead and changed it here. If we're going to put it into y equals mx plus c form now, I need to distribute. So negative 1/5 x plus 2/5. When I subtract that 5, that's going to be negative 1/5 x plus 2/5 minus 25 over 5, because I have to get a common denominator. So think about the 5 being over 1. I need it to be over 5, so I multiply the top and the bottom times 5. So that gives me y is equal to negative 1/5 x minus 23/5. Now, If you don't like that way, or you like the way that I did it earlier, you can take this form right here, plug your slope into it, plug your point into it, and solve for c. Just to get you started on that, if I plug that y and x in, -5, my slope was -1/5, my x is 2, plus c. Solve this for c, and then go back and rewrite it. So -5 would be -2/5 plus c. When you move the 2/5 to the other side, you end up with this. Now, I skipped some steps there. I would have to get common denominators and so on. But there's my c, and of course my slope was over here. And then it's just plug and chug. Y is equal to -1/5 x minus 23/5. Okay, so you get the same answer either way. Okay, 2 more here and we're done. Write the equation of the line that is perpendicular to the given line and passes through the point -9, 3. Okay, so to write an equation of a line, I need a slope and I need a point. I've got a point, I need a slope. And specifically, I need a slope that is perpendicular to this line right here. So let's find that slope first. Let's make it equal to y. 3x minus 18 is equal to 2y. So I move the y to the other side. Divide everything by 2. 3/2 x minus 9 is equal to y. So my slope is 3/2. Well, but I want a perpendicular slope. So my perpendicular slope would be -2/3. Okay. So now, there's my slope, there's my point. You pick whichever way you want to do it. This one I'm just going to do one way. I'm going to do it just by plugging it into the point slope form. But if you like doing it into the slope intercept form, that's fine too. That's going to be y minus y is equal to my slope, x minus my x, so that's minus a -9, so plus 9. Okay, distribute -2/3 x minus 18 over 3. Well, luckily for me, that actually reduces to just give me 6. Y minus 3 is equal to -2/3 x minus 6. Let's go ahead and multiply. Well, we'll go ahead and add the 3. Okay, y is equal to -2/3 x minus 3. Multiply everything times 3. 3y is equal to -2x minus 9. And for it to be in standard form, I need no fractions, which is why I just multiplied by 3. But I also need everything on the same side and my x positive. So let's move everything to the side with the y, because that'll make my x positive. 2x plus 3y plus 9 is equal to 0. And the only one that you have to make positive is the x, but you do need to make them all be whole numbers. All right. And the last thing here, we have that 2 lines are perpendicular. Find the value of p. Okay, so what we're going to do is, if we know that these lines are perpendicular, we know what their slopes are going to look like. They're going to be opposite reciprocals. So let's put these both in y equals form so we can compare their slopes. So the first one here, that's going to be px plus 6 is equal to 6y. Divide everything by 6. And I get that. Okay, the other one here, solve that one for y. That's going to be y is equal to -2x minus p. Okay, now compare the slopes. The slope of this one here is p over 6. And the slope of this one here is -2. So if they are perpendicular, then they're opposite reciprocals. So this one, of course, is -2. This one right here, if this is -2, that means that the slope of this one would be the opposite reciprocal, which would be a positive 1/2. So I'm going to set these equal here and figure out what p is. So p over 6 is equal to 1/2. Cross multiply, 2p is equal to 6, p is equal to 3. Now, it turns out I don't even need this p right here. That was just really to throw you off. There we go. Right. So you have a lot of these same kinds of things. Some of them are using different skills in a question. It may not flat out come out and say, hey, find the intercept, but that's a skill that it's asking you to do. So solutions will be on my website. If they're not there yet, they'll be there soon. I'm still working them out. Tomorrow is a much shorter video. It's on solving systems of equations, which hopefully you remember, substitution, elimination, that kind of thing. And that's our brief run through of Chapter 3.